Alright, so chapter 2, lesson 5. Make sure you get this in your notebook. Percent of change. And you might be wondering what this is. What's percent of change? So think if you go to the store, and the first time you go to the store, the tennis shoes you really want are like $49.99. Usually they're higher than that, but we're going to pretend that these are cheap tennis shoes. Okay? And then you go back to the store like a week later, and the prices drop to like $41.99. So it started what, $44.99 or something, and then went to $41.99. Okay. So see how it dropped? What we're gonna do is we're gonna find the percent that it decreased today. Okay? And that happens a lot. Like you go to the store and you see something like, I don't know about you guys, but I'm a really picky shopper. Like I have to go and look at something like, I don't know, do I really need it? This is how much it costs. And then I go back later and I'm like, oh, it's still here. I still really want it. Now maybe it went up. Well, now I'm not gonna buy it. Or maybe it went down. All right, I'm gonna buy it. Okay? So we're gonna find out the percent that things either go up or either go down. And I think it's easier for you guys to think of like when you're shopping. When you go to look at the store, when you go look at some prices. So if you're not sure, if you're kind of confused, think of being at the store. Okay. So the first thing I have for you is I have a few review questions from the other day. Let's just quick talk about these. Let's not answer, but let's talk about it. Okay. 25 is what percent of 130? Let's do the top one. Let's do that in proportion way. If you were to do that in proportion way, how would you solve it? How would you set it up, Jasmine? Okay. Okay. And this would maybe be x, and then what would you do to solve? Cross product, 25 times 100 divided by 130, bada bing, bada boom, you should get your answer. Very good. What about this one? How would I set this one up if it was equation style now, Cadence? Yep. Yep. Like this? Okay. And then what would you have to do for this one to solve? Jacob? Just multiply. Would you have to divide this? No, because you already have that variable by itself. Is everybody up to par on this stuff? Everybody remembers how to do it? Do you have that one way you really like in your head? Okay, I want you to stick with that way. Okay, I don't care what you see on the test. I don't care what way you do on your test or your quizzes from now on. You pick the way you like the best. Okay? So, I know it's a lot of vocab. What's that? You weren't done? Oh, we were just talking about it. You didn't have to write it down. Yeah, no worries. No worries. I want you to write these down, though. I know it's a lot of vocabulary words, okay? I know, so we have percent of change. Then you have percent increase, percent decrease, percent error, and then there's one more down here. Okay, let's not worry about that. So you got 4 vocab. 1, 2, 3, 4. I know it's a lot of vocab. We haven't had a lot of vocab in a while, Jacob. The amount a number increases or decreases. So the amount the number goes up or down. Some of these are kind of self-explanatory. Increase, something goes up. Decrease, something goes down. Remember, you don't have to write them word for word. So the thing about this lesson today is it's pretty easy, but everybody forgets how to do it. Seriously, it comes to tests, and people say, well, I don't remember how to do this. So make sure you take some good notes, okay, on it, just in case you need to look back. And honestly, it's pretty easy. You just have to remember how to do it. That's all. All right, so how to do this? Let me know when you're ready, Merrick. Okay, the good thing is we kind of talked about this already before the lesson. So, what you do to find percent of change. Okay, so this is like the equation for it. All right, so percent of change is equal. This is really the big part you need to write down. The amount of change over the original amount. So important. The original amount, so important. The amount of change over the original amount. Then you divide them and move the decimal 2 spaces, and that's it. Now I'll show you how to find these things. I'll show you how to find these things. Percent change, it can be increase or decrease, and then on top is the amount of change over the original amount. All right, so how to do this? Let's talk about it. So first we're going to talk about percent increase. Okay, so what happened? Let's pretend we're at the store. We'll pretend this is all money. Okay, so let's say you go to the store and something you want is $57. You go back a week later and guess what happens? It increased, which means what? Went up to what? 89. So the first thing we're going to do is we're going to find how much it changed. It went from 57 to 89. So the first thing I'm going to do is I'm going to subtract. How much money did this thing change? How much money? Changed $32, right? That's what the first part is. Because remember, it's like how much it changed over the original, remember? So we're going to put 32 on the top because this is the amount changed. And then what goes in the bottom again? The original amount, right? What was the original amount to start with, Jacob? 57. So now what we're going to do is we're going to divide these two things. Which one goes in the house? 32, right? 32 divided by 57. We're going to have to add a decimal here. Let's see, 57 times 4, maybe? 5? Okay. 25 to 28. So that goes up there. Okay, we're going to bring down another 0. And probably 57 times 6. 2. Which leaves me with 8. Okay, do you see how far I went? That's how the farther I'm going to go. I'm only going to go 3 spaces. You don't have to go forever. Okay, so if it's asking me what percent, though, what do I got to do to that? Move the decimal over. So my answer is 56.1%. That's how much whatever I'm going to buy increased. It increased 56%. That's a lot. That's my answer. That's it. Okay. Want to try another? Should we try another one? Okay. So 12 increased to 20. So I don't know. What's 12 bucks? That's 12 bucks. A shirt. Let's say your t-shirt. You went and saw this t-shirt. Oh, you wanted it. Decided, nah, too much money. Went back the next day. Guess what? Increased to 20. That would stink, right? So what did it change? I have to take 20 minus 12. What did it change? 8 bucks. Okay. What was the original cost? 12. Okay. Now I'm going to divide like I normally do. 5, 6, 7. Nope, 6. 72. Uh-oh, guess what's going to keep happening here? It's going to keep repeating. Do you see how it's going to keep giving 80, 80, 80, 80? So, if I know that, about what percent? 66.6%? That's how much that shirt increased. Oh, that'd be terrible. Yeah. You can if you want. If you want to put the repeating, you can. Yep. I probably should have. So far, so good? Guess what? Decrease is the exact same thing. The exact same thing. The exact same method. The exact same everything. Okay? Merrick, you ready? Okay. In your homework today, it's going to give you something. It's going to give you something that looks like this, like 12. What does it say? It says like 12 to 20. So you have to tell 1 if it increased, and then 2 you have to find the percent of increase. Okay. So it's not going to give you the words in there. It's just going to say like 57 to 89. Well, what happened there? Increased, right? Yep. I don't think you have to do that because if you would tell if it's a decrease, I know it's going to go down 15% or 20%. So you really don't have to if you don't want to. No worries. Yep, so I'll do a decrease one here. I'll do decrease here. Okay? Here's some decrease. So here we go again. We went back. What? I know, right? Went back to the store, found that t-shirt. Maybe I went back 2 weeks later, still $20. Then all of a sudden, guess what? It went down to $9. Holy cow, now I really got to buy it. So what did it change? How much money did it change? $11. 20 minus 9, 11. Okay. So $11. But what did it start at? 20. I'm going to do my math again. See, it goes in 5 times. And then it ends, actually, which is kind of nice. Yeah. Which turns into 55%. Right? This isn't so bad. So many people are like, well, counting on the test, I remember how to do this. Find what changed, put over the original, under the original, and then divide. That's all you got to do for these. And then this one. You want to try one by yourself? All right, try this one by yourself. Jacob. No, you can keep these the same. You can keep these the same. Started at 25.66, decreased to 21.99. Woohoo! You can. Yep. 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 That 66.6 one isn't repeating though. So let's see. This might take you a little while. Just a little bit. Honestly, don't go too far. I don't. Yep. And even for this one might take you a little bit. Remember, you gotta move your decimal. Wait, right? What's happening? There we go. So once, for sure. Don't hurt yourself. Don't go out too far. And don't forget to move your decimal over because you need a percent yet. Let's see. That's a lot. Let's see, I think it goes in 4 times. Is that right? What's that? I hope not. It might say round to the nearest tenth. It's most likely what it'll say. So if you did it, you can stop here if you're here. Did you get about 14%? Move your decimal 2 spaces, should be about 14%. Hopefully you don't have any too long ones like that on your homework. Does everybody understand how this is working today? Any questions so far? Just follow your notebooks. Seriously, use your notebooks to help you. I have one more thing I'm going to show you, and that's this percent error. So like percent error would be like, let's say, I'm probably going to be at your house in 20 minutes, but you really get there in 23 minutes. I want to know the percent that you're off. That's what the error means. But like, has anybody ever has there ever been like a jar of jelly beans somewhere and they say, well, guess how many jelly beans are in this jar? You ever heard that before? And maybe you guess 98 jelly beans, but there's really 249 jelly beans. You want to find the percent that you're wrong. What's the error? What's the percent error? How much were you off? That's what percent error is used for. Okay. So it's the same thing, the amount of error. So you're going to subtract again over that actual amount, not the original amount. This time it's the actual amount. So that's really important to remember. Over the actual, not the original amount you said, the actual amount that it took you to get there. So that's a little difference between percent error and percent increase or decrease. Okay. Sometimes it might not deal with money. It's more like guessing things or like time or things like that. It's most likely not dealing with money. The biggest difference is this. The actual amount goes on the bottom and not the original amount. That can screw kids up once in a while. Because they might say, well, the original amount was what I said would happen. Well, that's not true. We want to know the original. Well, how much was in that jelly bean jar? How long it took you to get to that place? So usually when they do that, they're going to give you an estimate. They estimated 45 minutes, but it actually took 30 minutes to get somewhere. So you're going to do the same thing here, the first thing you're going to do. So like, let's say I estimate it's going to take me 45 minutes to get to school, but it really only took me 30 minutes today. Okay? So the first thing I'm going to do is I'm going to subtract. What am I off? How many minutes am I off? 15 minutes, right? What's my actual amount it took me? 30 minutes. Now I'm going to do my division. So this is the easy one. So how much was I off? I was off 50%. Holy cow. That's a lot. That's bad. That was a bad guess. I'm off 50%. That's a bad guess. Yeah, half. It's bad. Okay. And like another one, they might have you use Skittles. Like I told you, like the jelly bean jar. They might say, well, I'm guessing there's 134 Skittles, but there's actually 203 Skittles. Okay? So the first thing I'm going to do is I need to subtract to figure how much I was off. How much am I off? Let's see. I'm off 69 Skittles. Darn. And then my actual will be 203. And then I would use my division to figure out Skittles. 2 T's. Do my division to figure it out. Let's see. Probably 3 times. It's got to be 3 times. 2, 6. Guessing. Let's see. So I get 1. Probably 4 times. 4 times would be 8, 12. Oh, it's still only 3, isn't it? Oh my goodness, so close. Let's see. 201. Got it. So 4, 5, 6, 7, 8. Probably close to 8. Maybe 9. 7 carry 2. Yeah, I suppose it's this, isn't it? 9 times? Is that about right? That's what you guys are getting? Anybody? Yeah? You can stop there, that's fine. So I'm off about 33.9%. Everybody good? Okay, so here's the thing. In your homework today, it's going to have a lot of goodness. Sometimes it's going to ask you to have 2 answers. Why don't you open your book and we'll talk about it? Okay, why don't you open your book and we'll quick talk about it.